Welcome in the second section of our course. In this section, we'll be performing video classification using RNN and LSTMs. At the beginning, we'll focus on generating input video data. Once we'll have generated data, we will be creating a neural network for video classification. This is not all that we need. Once we will create a network, we need to enrich it with adding RNN and LSTMs to network to perform a task in a better way. Finally, we'll be doing testing and validation of deep learning model. And this is a first video in which we'll be generating input video data. So we'll be generating input video and we'll be creating MP4 files for different kind of shapes. Finally, we'll be adding txt file with labels per frame. So our video will consist of multiple frames and every frame can show different kind of shape. So we need to label it to be able to use it then in deep learning model. So let's go to the code. So here is our video classification example, and the first step, one of the first one, is generate video data if needed. So let's look at this method. We will see that if the generate data is set, we will start generating data using generate data method. That method is taking the path where that data should be generated, and if that path doesn't exist, it creates one. And once we have that, we are using video generator class to generate video data. We are using the path, file prefix will be equal to shapes, number of videos to generate will be equal to 25, we are specifying number of frames, so every video will have 150 frames, width of this video will be 130, and height will be also 130. We are specifying that we want to have 3 shapes per video, so there will be transition between those shapes, but we are sure that every video will have 3 different shapes. Next, not important parameters, so let's look at the generate video data method. So for number of videos, we are iterating over it and creating video path from MP3 and txt, because we will need those 2 files. First one to generate actual content with frames, and second path to create labels for that specific video. Once we have that, we are issuing generate video method. So this method is important because it performs actual generation and saving. So let's look at the core method that is called generate and save images, returning labels. So it takes a path, number of frames with high number of shapes, some kind of the random thing, background noise, and all the things that are not important to us so much. So that method basically iterates over number of frames and generate random frame, but it is generated from the finite number of sets. So it will be generated 4 shapes. So at the beginning we can see that we will have 4 number of shapes. First one that will have label equal to 0 is a circle, then 1 square, 2 arc, and 3 line. So there will be transition between those shapes. As we requested, 3 shapes should land in the one MP4 video. So here we have a switch that creates a specific content. So we are filling our video with ellipse 2D or rectangle, arc 2D or line 2D. Everything from here is used from the Java AWT geom. So this is already existing in JDK. Next, we are creating other shapes and iterating labels. So up to this time, we will have MP4 generated, but still we need to leverage those labels to train our models. So we will see that generate video method is returning labels. So let's look where this is used. So we can see that here we have labels and we need to write labels to the text file. So we are taking labels path and labels. So for every label, we are iterating over it and creating new. So we are leveraging that we can append new label to the string builder, and at the end we are just writing a file with UTF-8 formatting and we are appending that to the content. So leveraging the fact that the structure of our processing will be MP4 file and text, we will see how this data does look like.